Remember that surds are just irrational numbers which are written with square root or radical symbols. Sometimes when you are looking at mathematical expressions, you'll need to add and subtract surds to simplify the expressions. And you have to do this carefully because we can only add and subtract like surds. Okay, so for example, here we've got two surds, 3 times the square root of a and 7 times the square root of a. Those are like surds because the number under the square root symbol is exactly the same, a and a. On the other hand, this example 5 root a and 10 root b are not like surds because the number under the square root is a different thing, a and b. So we can't combine those through addition or subtraction. You might see that this is kind of similar to algebra. We can't add a and b unless we know what the actual values are, but just as symbols we can't combine them through addition. We could, however, add 3a and 7a and get 10a. So it works similarly here with surds. So what we're going to do is take a look at a couple of examples, gradually getting more complicated, but basically showing through the idea of how to combine these things through addition and subtraction. So let's look first of all at the following expression. 3 root 7 minus 6 root 11 plus 12 root 7 and 3 root 13. So we've got 4 terms, 1, 2, 3, 4. All of those are surds. We can see the numbers under the root symbols there. What I can also see is that I've got a couple which are like surds. These ones though are not. So we've got 2 involving the square root of 7. So I can combine them through addition in this case. We've got 3 root 7s and 12 root 7s. So 3 plus 12 gives me 15 of them. But I can't really do anything with the other 2. We'll just leave those as 6 root 11 and 3 root 13. And that's it. So that is the simplified version of that expression, just through combining the like surds. Okay, let's bring in some pronumerals, some letters. Say we have 3 times the square root of x, take away 2 times the square root of y, and let's add 5 root x. Okay, again, we've got a something minus something plus something. So in those terms, we're looking for like surds. That one's not. So we've got square roots of x and square roots of y. We can combine the root x's. We've got 3 of them and 5 of them. Through addition is going to give me 3 plus 5 is 8 root x. And then we're just left with the root y term as it is. Again, similar to algebra, we're just combining those like surds, but not the ones which are not like. Okay, let's ramp it up a little bit more. I'm going to say 5 root 3 plus 7 root 12 minus 3 root 2 plus 4 root 8. Now again, we're following the same idea. We can only combine like surds, and in this case, I can't see any like surds. We've got root 3, root 12, root 2, and root 8. So it doesn't look like there are any like surds. But if we remember, when we write surds, we always like to write them with the number inside the root symbol as small as possible, removing any perfect square factors. Root 3 we can't really do anything with, but if you take a look at 12, 12 is equal to 4 times 3. And 4, of course, is a perfect square. So we can do a little simplifying on root 12. Can't do anything to root 2. Root 8, though, we can write as 4 multiplied by 2. And again, we've got a factor which is a perfect square. So we'll be able to simplify that one as well. So we should go through the simplification just for completeness, but also because it might lend itself to helping us to add and subtract terms. So moving down, we'll leave 5 root 3. 7 root 12 will become 7 root 4 times 3. 3 root 2 stays. And 4 root 8 will become 4 root 4 times 2. Now again, as I often say, when you've done a lot of these, you might not need to put this intermediate step in. You might be able to move to later steps more quickly, but just for now, I'll show you what I'm doing. All right, so we're going to do some simplifying here. We've got 5 root 3. Or before we do the simplifying, we might break up the roots. 7 root 4 times root 3. Take 3 root 2 plus 4 root 4 times root 2. Now we can get rid of those perfect squares. Root 4 is going to give me 2. Root 4 again giving me 2. So I can multiply through. We've got 5 root 3 plus 7 times 2 is 14 root 3. Take 3 root 2 plus 4 times 2 is 8 root 2. And now you can start to see some like surds in our work. We've got some root 3's there, we've got some root 2's over here. So we're going to be able to combine those through addition and subtraction as required by the expression. So 5 root 3's plus 14 root 3's is going to give me 19 root 3's. And minus 3 root 2's plus 8 root 2's will give me plus 5 root 2. And there we go. No more like surds left. Surds are in their simplest form, so we're complete with that example. Let's make it a little bit harder again and bring in some pronumerals to work on the next one. I might do this one in a little shorter way. So let's see, we've got 1/3 square root of 100 a to the 5b squared, a root 36a, and minus 4 root 4a squared b. So what are we going to do here? We are going to leave that 1/3. We're going to break this into the square root of 100. Now a to the 5th I'll write as a to the 4 times a. So we'll get root a to the 4 and root a. B squared, I can just write that as the square root of b squared. On to the next term, a times root 36 times root a. And then finally minus 4 root 4 root a squared root b. Now the way I've done it this time is to immediately break up all of the square roots into pieces and pull out the pieces which are perfect squares. There we go. So I'm going to simplify those down. Root a squared becomes an a, root 4 becomes 2, root 36 becomes 6, root b squared becomes b, root a to the 4 becomes a squared, and the square root of 100 is of course 10. So let's pop those together. We've got 10 a squared b all over 3. That's the 1/3 out the front. And we're left with that root a plus 6a root a. And then finally minus 4 times 2 times a is minus 8a root b. One more little step that we can go through here is to combine our like surds. Remember, that's what the whole video is about, so we better do it. So it's a bit hard to do this one, but if you think about it, we're factoring out the root a, but because of the nature of the way we write surds, we usually pop that at the end. So it won't be factored out the front of the brackets, it'll be factored at the end. So we're left with 10a squared b over 3 from the first term, plus 6a from the second term times root a, the term that, or the factor that we pulled out, and minus 8 times a times root b. We can't do anything with that because it's a square root of b, so a completely different surd. So there we go. That is our simplifying the surds when we're adding and subtracting them, remembering that we can only do that with like surds. And being careful that sometimes you won't see the like surds immediately, you need to do a little simplifying of how they look before you can go through with it.